What is the value of the definite integral from -1 to 1 of root of x squared? Is it A, 0, B, 1, C, -1, or D equals to 2? It turns out that 95% of students answer A. However, 0 is not the answer. So let's find out how come students got 0 when integrating this definite integral. So a common mistake is to assume that the square root of x squared is equals to x. If we assume that the square root of x squared is equals to x, and then we substitute that on the integrand, then we find the antiderivative of x, which is x squared over 2, and then evaluate from -1 to 1. When we evaluate from -1 to 1, this is equals to 1 squared over 2, when x is equals to 1, minus -1 squared over 2. So the first term is 1 over 2, and the second term on the right-hand side, -1 squared, will be positive 1. So we'll have 1/2 minus 1/2. And 1/2 minus 1/2, that is equals to 0. So that's how they obtain 0. But that is not the right answer. In fact, this is the wrong answer. So how do we evaluate this integral? Let's evaluate this integral the right way. So first we get rid of the root. And in this case, we use the right identity. And the right identity says that the square root of x squared is equals to absolute value of x. So we are going to use this identity to evaluate this integral. So first, let's substitute the integrand square root of x squared by absolute value of x. And now we evaluate this definite integral. When we evaluate an integral containing the absolute value, the first step is to use the definition of the absolute value function. And the definition says that the absolute value of x is x if x is greater than or equal to 0, or negative x if x is less than 0. So let's use this definition and let's evaluate this definite integral. Next, we express the integral as the sum of two integrals. On the first one, x goes from -1 to 0, and on the second integral, x goes from 0 to 1. Let's analyze the first integral on the right-hand side. X is greater than or equal to -1 and less than or equal to 0. Let's see what happens on the second integral. On the second integral, x is greater than or equal to 0 and less than or equal to 1. Since x is less than 0 on the first integral, then if we take a look at the definition of the absolute value, then the absolute value will be -x. Now let's substitute on the first integral the absolute value by -x. Now let's analyze the second integral. On the second integral, x is greater than or equal to 0. And by analyzing the definition of the absolute value function, when x is greater than or equal to 0, the absolute value of x is x. So now let's substitute on the second integral absolute value of x by x. Next, we evaluate these integrals. On the first integral, the antiderivative of -x will be -x squared over 2, and we will evaluate from -1 to 0. On the second integral, the antiderivative of x is also x squared over 2, and we evaluate from 0 to 1. Now we make the substitutions, and then we will have on the first term 0 squared over 2 minus -1 squared over 2. On the second term, we'll have 1 squared over 2 minus 0 squared over 2. And then on the first parenthesis, inside parenthesis, we'll have 0 minus 1/2 and -1/2. And on the second parenthesis, we will have 1 over 2. Now keep in mind that there was a negative sign outside the first parenthesis, so negative times -1/2, that will be positive 1/2, plus 1/2, that will be equals to 1. So that is the value of this definite integral. That is the correct answer.